In this example, we have a charged particle that is moving with a velocity of 5 times 10 to the power 6 meters per second in a magnetic field of 0.4 teslas. And we're told that we have a charged particle that is a proton. And a proton has a charge equal to that of an electron, but is positive. So it's positive 1.6 times 10 to the power negative 19 coulombs. And we're told that the angle theta, as shown in the diagram, measured from the direction of the velocity v and the direction of the magnetic field B, is given as 30 degrees. Okay, we're asked to calculate the magnetic force that would be exerted on this charged particle as it moves through the magnetic field. So this formula for this is Fb for the magnetic force is equal to, we're going to find the magnitude for now, the absolute value of that charge Q, or Q0, times the velocity, and times the magnetic field, and then times the angle, sine of the angle between the velocity and the magnetic field. Now, technically speaking, the magnetic force is really the cross product between the velocity and the magnetic field. And so if we're looking for the magnitude of that magnetic force, we're going to take the magnitude of Q, the magnitude of the velocity, the magnitude of the magnetic field, and then multiply by the sine of the angle between the velocity vector and the magnetic field vector. It's known as a cross product. You may recall that we saw this earlier. If you take any two vectors A and B, it is the magnitude of A times the magnitude of B times the sine of the angle. We saw the same formula when we did torque. Okay, so now you can substitute in your Q, your velocity, and the B and the sine of the angle. And there you go. And then go ahead and compute this on your calculator. Make sure your calculator is in degree mode. And this will give you the magnitude of that force of 1.6 times 10 to the power of negative 13 newtons. Okay, and now comes the fun part. You need to find out the direction of the force acting on this charged particle. And you will use the right-hand rule to find that direction of the magnetic force. So using the right-hand rule to find the direction of the magnetic force on a positive charge moving in a magnetic field, we have our fingers point in the direction of the B field, our thumb point in the direction of the velocity, and your palm will push in the direction of the magnetic force. So pull out your right hand. The common mistake people do here is that they write with their right hand and they forget to drop their pencil. So you have to put your pencil down, pull out your right hand, put your fingers in the direction of B, put your thumb in the direction of the velocity, all right, and see what direction the palm of your hand points. Let me show you a diagram for this. Well, there you go. You see your palm is actually facing directly up along this axis. So you can see the fingers are pointing along the plane of B. Your velocity is pointing this way. And then F would be pointing directly up here. So your force would be directed straight up along this plane. And there you go. We have the force directed upwards as shown in the diagram. And that's it for this example.